Hello everyone and welcome to our biggest project in this course, which is going to be the backdoor. Now, most of you will probably consider this one of the most important tools that we are going to code inside of this entire course, and you're actually right. The backdoor and the reverse shells are something that are used all over the world in penetration tests in order to gain access to the target machine and in order to execute commands, gather different information, or simply just spy on your target. In this project, we will code an advanced backdoor that will be able to do multiple things, such as execute commands, start a keylogger, execute screenshots. It will also be able to hide itself inside of a registry and also inside of a hidden directory. We will be able to upload files, download files, and just as a plus to all of that, we're also going to create a command and control server in the next project or in the next section, which will be able to communicate with multiple targets at once. So you will be able to infect multiple targets and execute commands on multiple targets simultaneously, as well as switch between different sessions. Alright? Now, before we even get to all of that, let's start off with the base part, which is creating the backdoor and the server. Yeah, that's right, we will need the server as well. We need to create two programs inside of this project. One program will be our reverse shell or backdoor, which we will send to the target system, and the second program will be the server, which we will run from our Kali Linux machine, and there we can communicate with the backdoor on the target machine. Alright, so without further ado, let's create those two programs. I already created the backdoor project, so all we're left to do is right-click on New, Python file. Let's create backdoor.py as our first file, and we also need another file which is going to be server.py. Alright, so we're going to code both of these programs simultaneously. Once we add a function to the backdoor, for example, we will also cover it in the server and so on and so on. And at the end, we're going to test these two programs. So let's start off with initiating the connection first. That's the first part of everything. Before we even execute commands or run screenshots, we need to gain access or gain connection to the target machine. So for that, we're going to use the socket library and double import it inside of our server, and I will initiate simple connection. We will create the sock object, which will be socket.socket. It will have the parameters of socket.af_inet, which stands for IPv4 address, and we will have another parameter called socket.sock_stream, which stands for TCP connection, as we want to have TCP connection with our target. Alright, now that we created the socket object, we need to bind it with our IP address and our port. For the purposes of this tutorial, we are going to set the port of 127.0.0.1 or simply just the local host IP address on which we are going to connect to during the first few phases of our backdoor. Later on, we are going to test it on real machines, of course, with the real IP addresses, but for now, this will be good. So we're going to bind the local host IP address with the port, let's say 5555. And you can choose any port you like, really, as long as it is a free port and nothing is being ran there. Alright, so now that we binded the IP address with the port, let's print to the screen that we are listening for the incoming connections. And just in case, why not add a colored function from the term color library in order to print this in different colors. So we are going to print this in green, that we are waiting for the incoming connection or listening for the incoming connection. Let's specify it in between the brackets. Listening for the incoming connections. Alright, and we want to print this in green. So let's specify green right here. And then we can listen for the connection. sock.listen, and we specify 5 right here. Now this number 5 stands for that we are actually listening for 5 incoming connections. But of course we are also going to manage one if we get only one connection. Alright, so now that we set up our listener for the connection, we can wait for the connection and then accept it as soon as it comes. We're going to create two different variables called target and IP, and those two variables are going to be equal to sock.accept. Now, inside of this target variable will be the socket descriptor, so we're going to use the target variable in further communication, And inside of the IP variable will be the IP address of the target machine as well as the port from where the connection is coming from. That will be stored inside of this. Okay? Now that we accepted the connection, we got the connection established, and we can print to the screen as well in colored. We can print target connected from, and then we can use from, and we can use our IP variable that we just declared right here. So we can simply just concat right here the string of the IP. Remember, the IP stores the IP address of the target, and then we want to print this in green. And we are missing one bracket at the end. Okay, so now it is good. Remember, we need to install the term color library inside of this virtual environment. So pip3 install term color. Okay, so here it is. Let's exit this terminal. And now this should all have a correct syntax. Okay, so now that we got the connection, let's go and do the same inside of our backdoor. So in our backdoor, we actually need to connect to this server. So we don't need to bind the ports or accept the connections. All we need to do is create the socket descriptor and connect to our server. So let's do that. We first of all are going to import the socket library. Then we will declare the socket object, and we are going to call it S instead of just sock, so we don't confuse these two programs. Inside of server, we're going to call it sock, and inside of backdoor, we will call it S. Alright, so S will be equal to socket.socket, and the two parameters should be the same as in our server, so socket.af_inet, once again for the IPv4 address, and then we need socket.sock_stream for the TCP connection. Right after we do that, we can simply just type s.connect and specify the IP address and the port to which we want to connect to. In our case, 127.0.0.1. And the port, if you remember, is 5555. Okay, so this should initiate the connection, and if we run these two programs, the backdoor will just connect to the server, and then the programs will be closed. So we want to also send some messages between these two programs, so let's go right here, and let's, for example, enter a function which we will call target communication. Right here. And inside of the target communication, we first of all need to define it, so target communication, communication. It will not take any parameters. All we need to do is to receive the command. So how can we receive the command? Well, we need to specify target.receive. We want to receive 1024 bytes, and we want to print to the screen the message. So we're going to store it right here inside of the message, and we're printing message right here. Okay? Now we also need to code the part inside of our backdoor. Right after we connect, we want to create a message. So message will be hello world. And then we want to socket.send the message. Simple as that. Let's see whether this will work. If I go to my terminal, and here if I run the server.py, name color is not defined. Wait, maybe we need to specify like this, term color.colored. Like this. Now it should work. Wait, let me just add it right here as well. So term color.colored. And another error that we have is right here. So it's not communication. So it's not like this. We misspelled this, so it's communication. Okay, so now everything should be good. Let's clear the screen and run it once again. We run our server. It will listen for the incoming connection, as it says right here. And if I go to my second terminal, let's lower this terminal so we can see both of them equally. And we go to the PyCharm projects and then backdoor, and we run the backdoor.py. it will give us an error that says a bytes-like object is required, not string. Now, if we ran these two programs with Python 2, they would work. But this is Python 3, and there is something that was changed inside of Python 3 regarding the socket library. Therefore, we cannot really print this, as the error says a bytes-like object is required, not string. So what we need to do is we need to encode and decode the message. The program where we're sending the message, which is our backdoor, has to encode the message before sending it. So we're going to add message.encode, which will encode the message, and inside of our server, which will print the message, it has to first decode the message, because we cannot print an encoded message. Therefore, we will specify right here message.decode. Just like that. Now, if we run the program once again, we first of all need to run the server, and then we run our backdoor. Everything will work correctly. We do not get any errors. We get these two statements printed, so listening for the incoming connection. Then once the target connects, we get target connected from the localhost IP address and from this port. And this was the message that backdoor sent to us. Okay, good. We managed to establish the connection, and this is the first part of creating our backdoor. In the next video, we're going to continue on developing this target communication function and see what else we can do instead of just sending the message. Alright, so thank you for watching this lecture, and I will see you in the next tutorial. Bye! Welcome back. Let's continue with the development of our target communication function inside of our server. Now, in the previous video, we saw how we can actually send the message from the backdoor to our server, and then we will print it to the screen. But we don't really care about sending messages back and forth. This is not a chat program, this is a backdoor, and sending messages is not a function that we need. So, the first and most important thing that we need our backdoor to do is to be able to execute commands on target machine. So that is what we're going to implement right now. If we go to our target communication function inside of our server, we can simply just delete these two lines, as we don't really care about sending messages. We can also lower this so we can see the entire program better. And then what we can do is we can prompt the user of this server to enter the command that they want to execute on target system. So let's create a variable called command. This command variable will take an input from the user as to which command the user wants to execute. We can specify something like this, so $sign and then shell. Let's make it look the same as Kali terminal, so we'll specify %s. So we can know which target are we communicating with, and then 2 dots, space, and right after it we can specify % and then string of IP. Remember, IP stores the IP address. All we're simply saying right here is that we want to specify the IP address instead of %s, so we know which target are we executing the command on. Alright? Once the user of the server inputs this command, we can send the command right away using target.send. But remember, we cannot really send simply just the command. It was something that we could do in Python 2, but we can no longer do it in Python 3, since we need to actually encode the command before we send it. So we're going to create a specific function which is going to use the help of JSON library. So we're going to import the JSON library, and we'll create a function called reliable_send. What this function will take as an input is the data that we want to send, or in our case the command, and then we need to create the data. So data will be equal, JSON data will be equal to JSON.dumps from the data that we specify, or from the command. After we do that, we can use target.send function of the JSON data, but don't forget that we also need to use the encode function before we send it. Since we are the one that are sending the message, we are the ones that need to encode it. The backdoor program will decode the message before executing it. Alright? Therefore, this is the entire reliable send function, and instead of the send function that socket library gives us, we're going to use reliable send throughout our program. So let's specify right here reliable send, and we will specify command in brackets. We're sending the command to the backdoor. As soon as we send the command, we want to wait for the reply, so we will create a variable called result, and that result variable will be equal to target.receive. Alright? And then as soon as we receive it, we're going to print the result. Now we need to cover these same steps inside of our backdoor. So let's go to our backdoor program and let's delete these two lines, which are from the previous video. As soon as we connect, we want to receive the command that we need to execute. Remember, our server is sending the command to execute, therefore our backdoor, first of all, needs to receive the command. So we can specify s.receive 1024 bytes, or we can create something similar to the reliable send function, just we can do it for the receive function. Since you will notice that this actual receive function takes a parameter of the amount of bytes that we want to receive, well, what if the command or the response from the server is larger than 1024 bytes? In that case, our program will crash, and we don't really want that. So let's create a function that will be able to accept and receive any amount of bytes that the server sends. So let's delete this, and we will simply just create a function called reliable receive. This reliable receive function will declare a variable called data, which will be empty at the beginning. Then we're going to enter an infinite loop or while true loop, which is going to try to receive the data. So data will be equal the previous data plus socket.receive 1024 bytes. And we also want to decode the response, remember in Python 3 we need to decode, and we also want to perform the rstrip function onto it. Since we don't want any new line characters or so on and so on, we want to print it as it is. Then if that is all, we can simply just return this data. We're going to return it with the help of the JSON library, so we're going to use json.loads onto our data. And in case we didn't receive everything, in case we get a value error, so except value error, we want to continue with the execution. Alright, so this is our entire reliable receive function, and you will see that the JSON is red underlined, so therefore we need to import it inside of our backdoor as well. So import JSON. And also don't forget that inside of our server, don't forget to encode the data before sending it. Since here we're going to decode it, and in case you forgot to encode the data before sending it, this will try to decode something that's not even encoded, and it will result in error. Okay, so now that we got these two functions, we're ready to receive the command. Let's create a variable which is going to be called command, and that command will be equal to reliable.receive or _receive. Once we receive that command, we can execute it right away. But before we execute it, we need to import a library that will allow us to do that, and that library is called subprocess. So type here import subprocess, and with the help of this library, we're going to execute the command that the server sent. So let's specify right here, execute will be equal to subprocess.popen, which stands for process open. We want to open the command or execute the command. And there are some parameters that we also need to specify, such as, for example, shell equals true. We also need the std out to be equal to subprocess.pipe. And two more parameters, std err has to also be equal to subprocess.pipe. And std in has to be equal to subprocess.pipe. Okay, so with the help of this execute variable, we can execute the command that we received. After we do that, we also want to gather the result of that command. So that command will have some type of output, and we want to take it and store it inside of a variable. So we'll create a variable called result, and that variable will be equal to execute.stdout.read plus execute.stderr.read. And then we want to send this result back to server, so the server knows what is the output of this command. And we're going to use reliable send. To do that, we will send the result, and keep in mind we do not have reliable send inside of our backdoor, so let's just copy it from the server, copy, and paste it right here. There are a few things that we need to change, such as, for example, we are not using target socket descriptor, which is only to be found in server program. We want to use the S, which we created to be a socket descriptor inside of our backdoor. Everything else will remain the same. We will encode the data and then we will send it. Inside of our server, we also need to receive that data. As you will see in our target communication, we're using target.receive, but we don't really want to use target.receive. We want to use reliable_receive. We'll specify it like this, and we need to copy the reliable.receive from this program, from this backdoor, to the server. Once again, switch the socket descriptors from the S to target, and everything should be good to go. Once we print the result, the program will close. But why execute only one command when we can iterate inside of a while true loop and execute as many commands as we want? So all we need to do is tap all of this inside of a while true loop, and it will prompt us infinitely to input the command, and it will also send the command and wait for the result. We also need to do the same inside of our backdoor. So right here, we're going to copy all of this, copy, then we're going to delete this, and let's create a function called shell, define it right here, shell, and paste our code. Wait, let's move this back to its line, and all we need to do is create a while true loop as well here, as we did in our server. And let's add it right at the beginning. So while true, we want to receive the command, we want to execute the command, we want to store the result, and we want to send the result. But this will present us a problem. If you think about it, we don't want our programs to run for infinite amount of time, so we need to have some indication or some type of a message that will tell the program that we no longer want to execute the commands and that we want to close both of these programs. Well, that is rather easy to do. Let's go to our server, and inside of our target communication, and after we send the command, what we can do, we can simply compare if command equals to quit. Then what we can do, we can break out of this infinite loop and close the program. By breaking out, this program will close automatically because it reached the end of the program. Okay? So we need to do the same inside of our backdoor. Just keep in mind that before you actually compare these two values, you first of all need to send the command so that our backdoor can also receive the quit command and then close its own program. Once we receive the command, we can go right here and check if command equals to quit. Then we break out of this loop and close the program. Alright, so we got quite a few functions coded in this lecture, so let's test it out and see if everything works. Let's open up the terminal and run server first. It will listen for the incoming connections. Let's go for another terminal and run our backdoor. So Python 3 backdoor.py, and we can see that the programs this time didn't close, so we are waiting for an input from the target. We got shell as well as the print of the IP address and the port from which the connection is coming from, and let's say we want to type the command who am I. Press enter, and it seems that we don't really get the response, and right now let us Control-C this and find our error. Inside of this program, we get an error which says object of type bytes, it's not JSON serializable. and the error is inside of our backdoor. If you scroll all the way down, right here, the part where we actually execute the command is the part where our programs fail. And the reason is because we're missing one line. Right after we stole the result, we need to add another line which will say result equals result.decode. And the reason for that is we need to decode right here first because the above command stores a bytes type result that we can't encode as a string. Therefore, the result has to be decoded first before we use the reliable send function onto the result. And remember, the reliable send function encodes the answer. Okay? So, right here we decode first, then we encode and send it, and now let's see whether this will work. Python 3, server.py, listening for the incoming connections, and right here we got the connection. Let's execute the command whoami, and now everything seems to work correctly. We get the output which says root, and we also get the prompt to enter the second command, so let's type ls, and the ls command works as well. We got all three files that are in the current directory, which is backdoor server and virtual environment. If we type, for example, ifconfig, we will get the output of the command ifconfig with our IP address right here. And now finally, let's test the quit command, whether it will quit both programs. If I type quit, press enter, it closes the server and it also closes the backdoor. So our program works really well for now. And now that we got the basic part of the program completed, which is executing the commands, we can keep on adding different functions to our backdoor. We're going to continue in the next lecture, so hope I see you there and take care. Bye!